Hello, everyone. My name is Vanshu Mule, and this is my progress presentation for Project A. My project explores how we can predict tennis match outcomes using two different approaches: a statistical model called a logistic regression and a rating-based model called ELO. I'll be sharing the background, my early results, and what I plan on to do next. So, moving on to background and motivation. Sports is something that has been intriguing to people since ages, and with sports gaining such popularity all over the world, it has become a huge market. And with a huge market comes analysis. Now, analysis or forecasting for sports has become slightly tricky and is a bit challenging due to the constant evolution in players, their playing ability, the performance, and the factors that might affect their play. A perfect example for this test could be tennis. Tennis is one of the most popular sports and has some serious historical data available, which is a gem for training and testing data models. Insights from these predictions can be leveraged by the players and coaches to understand and elevate the player's performance as well. So, there are two widely used methods. One is logistic regression, which uses historical patterns to estimate win probability, and ELO, which focuses on updating player strength dynamically after each match. So my aim is to see how these two compare on real ATP dataset. Now, moving on to research question. Yep. My research question is, how do rating based and statistical learning models differ in their ability to predict ATP match outcomes? And under what context does one outperform the other? My central question guiding my project is how rating based models like ELO and statistical learning models like logistic regression differ in predicting match outcomes. But more importantly, under what match context, such as surface type, tournament level, or ranking difference and methods, which perform better than other. On the right, I've got a prediction model cycle that I've been following or going about. I'll tell you how I have been going about it. Point one in the yellow. So that's me selecting the match context, having the predictors set, and then I have moved on to two and three, which is applying the rating based model and my statistical learning model, which is logistic regression. I won't be talking about ELO model today because I have just started with it, but I have early results and ED and everything done with logistic regression, which I'll be focusing on. So I have calibrated and evaluated the models, and I plan on evaluating prediction and accuracy for both, and then identifying uh, in the final model, which is six, which model performs better. So on data set, when we come to data set, I have been using Jeff Sackman's ATP data set. It is available on GitHub and it has data for women's and men's, but I will be focusing on men's data set. Uh, so far, I have used the data from the year 2000 till 2010 as training and 2011 for my testing. And I plan on extending the training to 2018 and then testing on 2019 as well. So the bar chart on the right, this shows how many matches were recorded each year, and it just confirms that we have consistent coverage across the seasons, which was kind of important for the training model as well. And I have added two more columns. One is the outcome variable, and the other is ranking point difference, which was my predictor. And um, the outcome variable was whether higher ranked player won, and if the player higher ranked player won, it was coded as one, and if not, it was zero otherwise. And the key predictor, which is the point difference between the two players, it was done. It was I used the formula winner rank minus losers rank point, and then we got those values. Now moving on to models. Here's my first logistic baseline model that I've fit, and I've just used a simple logistic regression model. This it just estimates the chance of the higher ranked player winning based on the point rank difference. Mm, and there was no intercept term as well, which the zero shows. So here are my first results. If you look at the summary over here, let me just zoom into it. Yeah. If you just look at the summary from the model that I have fit, the positive coefficient estimate of 9.260, that tells us that as the ranking point difference increases, the probability that the win also increases. The probability that the higher ranked player is going to win also increases. And if we look at the p value over here, it's um, it's not significant, but that's because the data is nearly perfectly separated and the pattern is already so clear that the model hardly has any uncertainty left. But if we look at the deviance, it drops from 47,000 to 61, which just shows that the model fits data pretty well. And coming on to the scatter plot over here that I have, just these red dots, they show these, each dot is a match. So the horizontal axis is ranking points difference, and the vertical axis shows whether the high rank player won. You can see in the scatter plot that as the ranking point difference increases, as the ranking point difference increases, the outcomes quickly become all wins for the higher ranked players. So this gave me a clear statistical baseline before moving to a more dynamic model. Next, we go on to model evaluation. Oh, sorry. Yeah. So I calculated accuracy and the ROC and AUC values. So the model achieved a 99% accuracy, and meaning it correctly predicted almost every match. But for that reason, I also checked out the sensitivity and the specificity values to see how well the model detected the wins and the losses, and they were nearly perfect as well. So it just confirmed that the model truly performs pretty well and has no imbalances. If we look at the ROC that I have here, the ROC curve evaluates how well the logistic regression model distinguishes between wins and losses. Uh, if you see over here, the curve rises sharply over to 1, which is the top left, which means the model achieves very high sensitivity while maintaining almost perfect specificity. In simpler terms, we could say that it's doing an excellent job of predicting when the high rank player wins and when loses with an AUC of close to 1. And this suggests that the ranking point difference alone is pretty strong predictor of match. Now, moving on to the next slide, what's next? Okay, so as I said in the start that I have just recently started implementing the ELO model, and the thing with ELO is that unlike logistic regression, ELO updates a player's rating after every match, which reflects their momentum. So what it is like, let's say when we look at the adjustment cycle over here, the players have an initial rating. So player A and player B have an initial rating, and then whoever wins the match, if player A wins, his rating is increased and player B's rating is decreased. So how does it do it? It uses this formula at the bottom. uh, EI and EJ is where the players ratings go, and I'll use the same data set to compare, so that to compare the accuracy and calibrate it. And after that, I plan to include surface and tournament tiers to see if the model performance changes, and also to extend my logistic and my ELO model. So for discussion and reflecting for what I've said, um, the logistic model gave me consistent accuracy and metrics on the training and the testing the data sets. Um, Ranking point difference is, according to the metrics, is pretty strong predictor so far, and I will be integrating ELO for a more dynamic comparison and extending it. And then for future improvements, I will be adding more factors like surface types and tournament tiers
and stuff like that. Thanks.